Welcome to another Mr. Paul video. Today we're talking about one-step equations. And before we get started with one-step equations, I think it's important to kind of clear up a few things, to re-understand what it means to solve equations. There's a big misconception, a lot to do with solving equations that I think has to get cleared up before we do any more videos or any more learning with solving equations, with dealing with algebra. So I want to start off with what does it mean when I say algebra? What exactly is algebra? And if you ask your classmates, they might say it's something in math, or you ask a professor, they'll give you a nice, very long answer. But you can think of algebra as a way of finding missing values, finding a piece that's missing in math, okay? And what tools do we have to solve these mysteries, to solve for these unknowns? And the answer is we have basic mathematical operations, meaning the first four that we've ever learned. We have multiplication and division. We have addition and subtraction. And it should be noted that I labeled them in this order for a reason. Multiplication and division are a lot alike. They're actually opposites of each other. When you are taught to multiply, the very next thing they teach you is how to divide, because they are opposites of each other. To undo multiplication, you have to divide. To undo division, you have to multiply. Similar in a way, and probably easier to understand, is addition and subtraction. They are also a pair. When they teach you how to add, they then teach you how to subtract. When you count up, they then teach you to count down. When you're adding something, to unadd something, you have to subtract. To unsubtract something, you have to add. Okay, so we will be using this idea of what's called inverse operations. Okay, inverse operations. And basically what that means is we are using the opposite operation. Okay, to be able to deal with some of the algebra. Okay, and I'll explain what I mean when we get to the steps. But do know that we're only using these four tactics. Okay, a couple of other things I should probably clear up are some common misconceptions of this. And I ask you what this symbol is, and you're like, that two lines, I've seen that my whole life. That means it's the equal sign. And I'm pretty sure I know what that means. And I just want to stress, the equal sign in words, because symbols are just replacements for words, literally means is equal to. Is equal to. That's all it means. And what it does not mean, and what we're so accustomed to, is the equal sign does not mean the answer. So for example, what this mathematical operation is saying, this is an example of an equation, and equations are what we use in algebra. If we have a question mark, meaning some unknown number, plus 3, and it's equal to 5. This does not mean that this side is math and this side is answer. What I mean to say is if I was to write this exact thing, but in the opposite direction, such as 5 equals 3 plus question mark, it would mean the exact same thing. And I cannot stress this enough, because we will be building on this idea of what equality actually means. Okay? We could think of it like a balance. On one side of my balance, I have a certain weight. On the other side, I have something else that weighs equally the same. Okay? So maybe like a brick, which weighs a pound. And then on the other side, I have a weight that weighs a pound. The scale will remain equal. If I were to add a brick to one side, mainly the side with the brick, it would go like this. I would have to add one more weight to the other side, or another brick, which I know to be the same size as the weight, to even them back out. What this equal sign means is that both sides are balanced. Whatever's on the left-hand side of the equation is equal to whatever is on the right-hand side of the equation. On the left-hand side, we have what's called an expression, a statement. On the right-hand side, we have a number. What we're saying, what this mathematical equation, because it has an equal sign in it, is saying is that this expression is equal in value to the number 5. And our job is to find out what this question mark has to be to maintain that both the left side and the right side remain equal. Okay? This might be the first time you've thought about it this way, but this is going to be something that's fundamental to our understanding of algebra. So it doesn't matter the fact that it's on the left or on the right, because whatever's on the right has to be balanced, has to be equal in value to the stuff on the left. And we will be building on this idea over and over and over. So when you see me doing mathematical operations, meaning multiplying, dividing, adding, or subtracting to one side of an equation, I'm going to be doing the same thing to the other side as well to make sure that both sides are balanced. Because just like in our brick analogy, if I add a brick to one side to make sure that it's balanced, I have to add a brick to the exact opposite side because it's balanced. Okay? Now I'm going to erase this piece for a second, and we're going to focus on our example. And we're going to go through an example of multiplication, division, addition, subtraction. We're going to go through a few examples in this video where we can solve equations like this. Okay? Now this particular equation, most of you have seen addition before, and you're like, Mr. Paul, wait a second. I know what the question mark has to be. I know what this question mark should be equal to. And because you've added a lot in your life, you would say, okay, this question mark, it has to be equal in value to 2. Because I know the only thing that can add to 5 when combined with 3 is 2. So what you're saying is 2 plus 3 equals 5. And I agree with you. This one isn't all that tricky. But what I want to start doing is, instead of using this setup, what I would like to do is write it in a more algebraic way. Because in math, they don't use question marks. This question mark is basically a way we can conceptually understand what's going on. So for example, if I was to write it with the proper algebraic language, if you will, we don't use question marks. We instead use a word called a variable. Okay? Typically, it's X or Y or Z. And for our examples, we're going to strictly use the X. So I'm going to erase these other two. But do know that you could see a Y or a Z, and all that means is they are unknown numbers. We are going to use X. So when in the equations, when you see us put an X, you could think of the X like a question mark. X plus 3 equals 5. This is the same thing as this. So try and train your mind. When you see an X, we're solving for the unknown number. We're solving for the question mark. So when we say that X is equal to 2, we're not saying the answer is equal to 2. We're saying that the missing value is equal to 2. The answer is that the missing value is 2. This whole piece is the answer. When the missing piece is equal to 2, 2 plus 3 equals 5. I can't just put the question mark. I can't just put a 2. Okay? Now, this one was easy to see because of our understanding of addition. We've done enough addition before. We kind of understand what it should be. But what I would like to shift focus on is, instead of just seeing it, because sometimes we can't see it. Sometimes it's harder for us to see. I would like to start showing you what we can do mathematically using those 4 basic operations, 2 equations, to be able to solve them. Okay, to be able to come up with where this 2 comes from. So I'm going to erase this, and I'm going to show you mathematically what we can do and what our overall goal is when solving equations. How do we get from X plus 3 equals 5 to X equals 2? If I can somehow get to what the value of X is, and say on the other side is equal to 2, you could think of it like the balance where x is on one side and whatever x is supposed to be equal in value to is on the other side. If I can get to this point, then I know what x should be in the original equation to make both sides of balance, to make them both equal. So the mathematical steps work like this, and we're going to use opposite operations. So we'll take this exact example and we'll do one more just like it. X plus 3 equals 5. And how in the world do we get to this x equals 2 without just seeing it? Well, our first goal should always be to what's called isolate the variable, meaning to get the x by itself. On one side of the scale, we want to have x by itself. So currently right now, my x is on the left-hand side of my scale, of my equal sign. It's on the left. You'll notice I have no x's on the right. If I can get to a point mathematically where just x is on one side of the equation, whatever on the other side, in this case is 2, would be what the value of it should be. So if I see this 3 on this side of the equation with the x and I want to get rid of it, I don't want it there anymore. I wished that it wasn't on this side of my balance. I can remove it. Okay, and we're going to be building on the idea of zero pairs. A lot of you remember that from 7th grade, 6th grade. Or building towards an identity. That's a little bit more down the road, but I hope some of you have heard of it before. If we use the inverse operation, it allows us to take off the unwanted piece from one side of the equation. So for example, imagine this side, right, is one side of the scale, and this is the other. If I want to take something off of one side of the scale, what I have to do is use the inverse operation on whatever I'm trying to remove. So for example, this plus 3, the opposite of addition is subtraction. To remove this plus 3, I have to subtract 3. I am now removing 3, the number 3, from my left-hand side of my equation. If I take away a 3, you can think of this as some unknown number plus 3, take away 3. I added the 3 and I took away the 3. These were opposite. These create a zero pair, and we like to think these cancel each other out. They are no longer on that side. They become the additive identity, the 0. Okay, they add to equal 0, which means I don't have to put it there anymore. I cancel it out. You'll hear me using the words canceling out a lot because it's often termed when manipulating algebra, okay, when using tactics. So I took away something from one side of the equation. As you know, that affects the other side. Now it's unbalanced. To make sure that it remained balanced, I have to do the same thing to the other side of my equation. So it's the idea that if I had something that's balanced and I took away one brick from one side and I took away another brick from the other side, it would remain balanced. Whatever's left there has to be balanced. So if there's an unknown number, plus 3, take away 3, those cancel. The unknown number still remains there. And then on this side is 5 minus 3. That's 2. You'll notice I did the same math to both sides because I want to maintain that both sides are still equal. If I didn't do the same thing to both sides, they're obviously not equal, as we took the idea that they would become unbalanced. But you'll notice that x equals 2 is actually the answer that we knew it to be. This is an example of a one-step equation. An equation because it has an equal sign, one step because I had to do one mathematical thing, one operation, one basic mathematical operation to both sides of my equation to achieve my goal of getting x is equal to some number. And if I can do that, if I can manipulate both sides at the same time, once, twice, 3 times, it doesn't matter how many times I manipulate it, but if I can achieve the goal where just one single x is on one side of the equation, whatever's on the other side has to be what the value of x should be. And it doesn't matter if x was on this side and the number was over here. And it doesn't matter if the x is on this side and the number is over here. And I'll show you what I mean with the next two examples. Okay? So here's an example of an addition, right, that I had to counteract. I had to use the opposite operation of addition, which is subtraction. Another example, 2 plus x equals 7. 2 plus some unknown number is equal to 7. Again, I want my x on one side of the equation, and I want the rest of the numbers on the opposite side. So for example, I have x on the left. I don't want the regular numbers, they're called constants. I don't want them on the left, I want this x by itself. So I'm going to remove this plus 2, this is a positive 2, with a subtraction. I'm going to subtract this 2 from one side of my equation. Whatever I do to one side, I have to do to the other to maintain that both sides are equal. 2 take away 2, they cancel out. I'm left with just plus x. So on this side, I have x. 7 minus 2 is 5. And some of you have seen in the original equation, 2 plus 5. Remember, the unknown number we're suggesting is 5. Is 2 plus 5 equal to 7? Yes, it is. Okay. One other example with addition. 2 equals 1 plus x. 1 plus some unknown number is equal to 2. Again, I'm using examples that we know what the answer is, so we know we can practice the right way. And I stress, it doesn't matter if it's on the left or if it's on the right. It's a scale. They're balanced. It doesn't matter if the scale is facing forwards or backwards, which is why I stressed it does not mean answer and math. That's not what that means. But I am still going to manipulate both sides of the equation to where I get x just on one side by itself, which means I want this x to stay here, and I do not want this 1 here. This is a positive 1. I want to get rid of the 1, so if it's positive, I'm going to subtract 1 from this side of my equation. If I do it to one side, the mathematical operation, I have to do it to the other to maintain that both sides remain equal. 1 take away 1 is 0. It goes away. It cancels. Plus whatever that unknown number is just that unknown number. 2 take away 1 is 1. This is saying x is equal in value to 1. And it is what we thought it was. 1 plus 1 equals 2. This is saying when x is equal to 1, 1 plus 1 is 2. And that is correct. The left-hand side, it's 2. The right-hand side, when x is 1, is equal to 1. Similar in a way, the right-hand side is 7. The left-hand side is 2 plus 5. Okay? These are all examples of when you see addition to use subtraction. Let's erase these and do a couple more examples, but we're going to use those other operations. Now, I'm not going to do too many examples, but hopefully we get the idea, and we'll be seeing more practice of these basic operations in future videos. We've seen one with addition. Let's try one with subtraction. X minus 3 equals 9. Or 10 equals negative 5 plus x. Okay? Now I say that we're going to use the subtraction method because that's going to be the thing that we're trying to focus on. We're trying to deal with the subtraction part. And what I mean by that is this. We want to get the x by itself. Something is now being subtracted from the side with the x. We're trying to get x by itself, but we're adding a negative number, which also can be thought of as subtraction. So if I'm trying to get x by itself, I don't want this minus 3 here. To get rid of the subtraction, I have to use the opposite operation, which is to add. So I want to add 3. And if I add 3 to one side of the equation, I have to add 3 to the other to make sure that both sides remain balanced. X minus 3 plus 3, these cancel. We're left with just x on this side. 9 plus 3 is 12. When x is equal to 12, we're suggesting this unknown number is 12. 12 minus 3 equals 9. Great. 10 equals minus 5 plus x. We want the x by itself, but there's this negative 5 here. To get rid of this negative 5, yes, this x is being added, but I don't want to get rid of the x. I want to get rid of this negative 5. The thing you're trying to get rid of is telling you which operation to use. If it's being subtracted or it's a negative, we're using the addition, okay, the opposite. I want to add 5 to both sides. If I do that, I have x plus negative 5 plus 5, those cancel. I'm left with just x on this side. 10, I forgot to add my plus 5. 10 plus 5 is 15. I added 5 to both sides. 15, negative 5 plus 15, this side's equal to 10, this side's equal to 10. Okay, this is how we solve addition and subtraction. I know this video is long. I just give you a couple more examples using the multiplication and division. 4 times x equals 12, or maybe 15 equals 5x. Okay? I see some number being multiplied by 4. If we see multiplication, we have to use the opposite operation, which is division. What I'm allowed to do is divide by 4. If I divide both sides by 4, I'm using the opposite operation. 4 divided by 4 is 1, right? 1x. Whatever I do to one side, I have to do to the other. 12 divided by 4 is 3. This is saying is that unknown number, 1x, the value should be equal to 3. 4 times 3 is 12. 15 is equal to 5x. I don't want 5x's. I want just a single x. It's being multiplied, so I have to divide. Divide by 5, divide by 5. Doing the same thing to both sides of the equation maintains that both sides are equal. 5 divided by 5 is 1 times x. 15 divided by 5 is 3. These are both 3. These both express that x is equal to 3, x is equal to 3, and they're both the correct answer. 5 times 3 is 15. 5 times 3, this side is equal to 15, this side is equal to 15. Okay, and lastly, the division. I know this is long, just bear with me. If you have, say for example, x over 7 equals 1, or x over 2 equals 4. What value of x divided into 7 will give you 1? What value of x divided by 2 will give you 4? These are being divided, so I have to multiply. I'm going to multiply by the number that's being divided. Similar in a way, I'm going to divide by the number that's being multiplied. So I'm going to times this side by 7. I'm using the inverse operation, the opposite. If I multiply one side by 7, I have to multiply both sides by 7 to make sure that they're equal. These cancel, just similar in a way that these cancel, and this cancel. Sorry, wrong side. This canceled. This is still there. 7 divided by 7 is 1. That's what we mean by canceling. On this side, we have 1x. On the right-hand side, 1 times 7 is 7. What this is saying is when x is equal to 7, 7 divided by 7 is 1. Some number divided by 2 is equal to 4. This is being divided. I'm going to multiply by the exact same number, which is a 2. I'm using the opposite operation. So if I multiplied one side by 2, I'm going to multiply the other side by 2. If I do these 2's, 2 divided by 2 is 1. I'm left with 1x on one side. And 4 times 2 is 8. What this is saying is x is equal to 8. When x is equal to 8, 8 is the missing number. 8 divided by 2 is equal to 4. I apologize for the long video, guys. I know that I'm having to fit in probably about a year's worth of algebra into one video. I hope this helps. Please watch the next couple of videos as we see more and more practice of solving one-step equations and building on that to solve two-step equations and equations with variables on both sides. That's it for today's video. I do apologize for the length. Peace out.